If you want to master the Fourier series, watch this video till the end. For the introduction, I have brought you these two graphs. I want to talk about Fourier series. In these graphs, the behavior of function is repeated n times, as much as period. This is the period of sine as much as t. It's 2 pi. This is pi and this is 2 pi. Some of the functions are intrinsically periodic, like sine in this graph, but some of them are not. We limit them from a to b and expand them side by side to make them artificially periodic. So what? We can replace it by a bunch of sine and cosine and a constant number. Okay, as an example, take a look at this one. F of x, then a naught over 2 plus summation of an cosine n pi over lx from n equals 1 to the infinity plus summation of bn sine n pi over lx from n equals 1 to the infinity. Call this Fourier series. It's a bunch of sine and cosine and a constant number. You may have a question, what are these a naught, an, and bn, and l? L is 1/2 of period. L equals t over 2. What is an? An is the coefficient of cosine, and we will have an equation for that to find out its equivalent. And bn also is a coefficient of sine. Also, we will have an equation for that I will write down for you. I write them down, the a naught, an, and bn. A naught equals 1 over L integral of f of x dx from minus L to L. And A naught equals 1 over L integral of f of x cosine n pi over L x dx from minus L to L. And Bn equals 1 over L integral of f of x sine n pi over Lx dx from minus L to L. And you should consider that A naught has another equation like this: 2 times S net, the pure net, over time period. Take a look at this graph. If we have a function that looks like this, this is the upper side of x-axis and this is the y-axis. We should consider this surface plus or positive, this surface minus. We subtract the positive surface we subtract positive minus negative 1, and this is S of net surface. As I said, the Fourier series contains sine and cosine, a bunch of sine and cosine, and a constant number. We should not see the sine to the power of 2 or sine to the power of 3. Sine to the power of 2 equals 1 minus cosine 2x over 2. I write down this tip, which we should have sine and cosine in the simplest way. Okay, as I remember, I have brought you these two types of function. We have even function and odd function. In even function, the negative sign is being swallowed. It swallows the negative sign and it's symmetric to the y-axis. As an example, take a look at cosine function. This is cosine function which is symmetric corresponding to y-axis. Cosine of x. And odd function sends out the negative sign to the side of f function. And it's symmetric corresponding to the center of coordinate. As an example, take a look at x to the power of 3 function. This is x3. This is y-axis, it is x. We see that this is symmetric. This point is symmetric to this one. And in the even function, this point is symmetric to this point. That's it. The distance is equal. If it is a, this is a. Okay, as an example, I have brought you this one. They want to find out the Fourier series of the written function with period of t equals 2 pi. Our function is f of x equals absolute of x, and we see that it is limited to minus pi and pi. And firstly, we should draw the function graph. This is y, this is x, and this is absolute of x. If we consider this pi, this is minus pi, and you see that is limited between 2 points, and it has been made artificially periodic. And if you want to find out the Fourier series, I expand it side by side with the green color. This is 4 pi. This is 2 pi. And in this side, this is minus 2 pi. And this is minus 4 pi. Okay, we should write down the identity of Fourier series. Identity of Fourier series. As the first one, we should find out the period. It is 2 pi. We take a look and it has been repeated as much as 2 pi. This is 2 pi. This is 2 pi also. Here. Okay, I made a mistake in the last chapter. Is 3 pi. This is minus 3 pi. As the second one, we should write down the L. L is 1/2 of t. 2 pi over 2 equals pi. For the next step, we write down the A naught. A naught equals 1 over L, that is pi, integral of fx, that is absolute of x, d of x, from minus pi to pi. Okay, this is, as it is an even function, this point is symmetric to this point. As this is an even function, we can cancel out the absolute sign and consider 1/2 of the region. This is the 1/2 of region. Okay, we'll have 2 over pi integration from 0 to pi and x dx. If we integrate this, we will have 2 over pi. Integration of x is x to the power of 2 over 2 from 0 to pi. If we substitute the pi and 0, we will have 2 over pi, 2 over 2 minus 0 over 2. It's 0. Pi 2 is simplified with pi and 2 is sent out. We will have pi. This is A naught. We have another way to find the A naught. Consider these two S of net region. If you remember, we had A naught equals 2S of net over T. It's two triangles. We should find out the surface. The surface of a triangle is this is 2 base times height over 2. This is period. Our period is 2 pi. Okay, we'll have, it's just a substitution. 2, we simplify these 2's here. Pi times pi over 1 over pi. This pi will simplify, we have the pi. You can see that's the equivalent. Okay, we write down the AN, which is equal 1 over L integration from minus L to L of fx cosine n pi over L of x dx. It's equal to 2 over L, which is even function. We just solve the 1/2 of the region and multiply it by 2. From 0 to pi, fx is equal to x, and cosine n pi over L. L is pi and it is simplified with pi. Cosine of n x d of x. What do you prefer to solve this integral? We should use the component by component method or DI method, differentiate integration method. Component by component method. We differentiate from one of them and integrate from another one. It's better to differentiate from x because it is a polynomial phrase, and by 2 times of differentiation it becomes 0, and integrate from the triangular function. If it was sine, we integral from it. This is the x and this is the cosine of n x. If we differentiate, this is 1, differentiate another time, it becomes 0. We stop here. We should stop. We firstly differentiate from polynomial phrase, and if we integrate, it is 1 time 1 over n sine of n of x. If we integrate another time, it will become minus 1 over n to the power of 2 cosine of nx. We multiply x with this one with a positive sign, and 1 with that one with negative sign. Our integration is solved. We just multiply and summate the two phrases. I want to tell you a point that when you saw the sign, and take a look at the boundaries, because our boundaries is 0 and pi, and make the sign function 0, we don't write down this. It will just cancel out to make the solution faster. As I said, this phrase is 0, and we just write down this one. If we multiply by 0, will become 1 over n2 cosine of nx. Okay, we should consider a natural number for n. It is even or odd. If it was even, what will happen? And if it was odd, what will happen? We substitute our boundaries 0 and pi to this function. It will become 1 over n2 cosine n pi minus 1 over n2 cosine 0. Cosine 0 equals 1, and if it was a even number, n was even number, or n was an odd number, it will become, look, we'll have n2 in the numerator. Cosine of np, if it was even number, you can put 2 pi, 4 pi, 0 pi. It is all 1. 1 minus 1 will become 0. If it was an odd number, cosine p, cosine pi, cosine 3p, cosine 5p, it is negative 1 minus 1 over n2 will become minus 2 over n2. That's our solution to this integral. If we substitute, it's 2 over pi times minus 2 over n2 will become minus 4 over pi n2. That's our an. Okay, till this part we have find out that t equals 2 pi, l equals pi, a0 equals pi, an equals minus 4 over n2 pi, and we're gonna find out bn for the last one. And bn equals 1 over l integration from minus L to L f of x sine n pi over L x dx. If we substitute, we will have 1 over pi integration from minus pi to pi of absolute of x sine of n pi over pi x d of x. This is an even function. This is an odd function. If we even function times odd function makes an odd function times even times odd because makes an odd function. You can suppose even function as minus and plus and odd function as minus will become minus. And if we integrate from an odd function in the symmetric region, it will become 0. 1 over pi, this is minus pi over pi, it is odd function, its integral is 0. That's it. As a reason, you can draw this odd function. It is positive surface and this is minus. This will neutralize each other. Okay, as a conclusion, we have f of x equals a naught over 2 plus summation of a n cosine n pi over Lx n equals 1 to the infinity. We will have x equal absolute x equals a naught, which is pi over 2 plus summation of n equals 1 to the infinity of a n, which is minus 4 over n2 times pi cosine n x. That's our Fourier series of this function in this region. Derivative for its n is an odd number, which I have written lately. It is 1, 3, 5 and so on. We can write it down like this. 2 pi over 2 summation of m equals 1 over, it's a natural number, minus 4 over 2m minus 1 to the power of 2 pi cosine 2m minus 1 of x times x. You can open it up like this, pi over 2 plus minus 4 over 1 to the power of 2 cosine x minus 4 over 3 to the power of 5 to the power of 2 cosine 3x and so on. This is a naught, this is a 1, this is a 3. As a second example, I brought you this function. F of x equals absolute of x, and x is between 0 and pi with a time period of pi. We draw its graph in its boundary. This is x, this is y, this is x in the positive axis, This is pi. It is also artificially periodic. That looks like this. It's 2 pi and again minus pi. Our period is p or pi. Firstly, we should write down the identity of this Fourier series. Fourier series. It's t equals pi, L equals pi over 2, and that's it. As a first step, we write down A naught, which is equal to 1 over L from a start that is 0 to n pi and x d of x, which is just function. It's x will become x2 over 2 times L, which is 2 pi, 2 over pi, in the start of 0 to pi. We will have pi 2 over pi, which is pi. A naught became pi. Okay. We will solve for an, which is 1 over L integral of 0 to pi x cosine n pi over L x d of x, which is 2 over pi integral of this x cosine n times 2 pi over pi x d of x. Cancel out the pi. This is also an integral that we should use the component by component method. We use the I method or component method. We differentiate from x, which is 1, again 0, cosine 2 and x, integral from it, it's 1 over 2n sine 2n x, again minus 1 over 4 and 2 cosine 2 and x. This is with a positive sign, and this will multiply with negative sign. Again, our boundaries is 0 and pi. It doesn't need to calculate this multiplication because it makes the sign 0. And our final answer will become 2 over pi minus 1 over 4 and 2 cosine 2 and x. And we substitute the 0 and pi, which will become 2 over pi, and this minus 1 over 4 and 2. If we substitute pi, cosine 2mp, it's always 1, and 1 minus 1 will become 0. And we have to solve Bn, which is 1 over L integration from 0 to pi x sine n pi over L x d of x. It will become 2 over pi integration from 0 to pi x sine 2mx d of x. Again, we have to use component by component method in tabular form, which is look like this: C, B, C. X. Differentiation of x is 1, again 0, sine 2mx minus 1 over 2n cosine 2nx and minus 1 over 4 and 2 sine 2nx. This is positive, this is negative. Again, we have sine 2x, which is, it doesn't need to solve this, which is 0. If we put 0 and pi instead of x, we just solve for this. This equal to 2 over pi times minus pi over 2n minus 0. If you put x 0 instead of x, it becomes 0. Then we have it simplified 2 by 2, pi by pi, minus 1 over n. This is our Bn. Bn became minus 1 over n. Okay, for the final form, we will just write down our function that look like this: a naught over 2 plus summation of an cosine 2n pi over L, which is 0, and summation of n with the beginning of 1 to infinity minus 1 over n sine 2nx. That's our Fourier series. We can open it up, that look like this, plus we just put the numbers: minus 1 over 1 sine 2x minus 1 over 2 sine 4x minus 1 over 3 sine 6x, and so on. Okay, as a conclusion, I wanna tell you 3 kinds of this Fourier problem that you will face with them. This is I call this not even, not odd expansion. This function is not even and is not an odd function. Okay? We call this not even, not odd expansion. In this type of graphs, we do not, we have A naught, Bn, and An. The three ones appear in our Fourier series. In another type of expansion, it's called even expansion. Even expansion, which is an even function, as you can see. And in this type of expansion, we just have A naught, which is sinar even forms, and B naught is 0, Bn is 0, excuse me, Bn is 0, and we just simply write down the An, as you can see, 2 over L from 0 to L. That's it. And cosine n pi over L, this is our function d of x. Okay, for the third one, we call it odd expansion. We call this odd expansion. As you can see, this is a odd function which is symmetric to the center of the coordinate. It is symmetric to the center of coordinate. In this type of form, we do not have the An, and we simply write down the Bn, which is equal to, which is equal to 2 over L from 0 to L f of x times sine n pi over L d of x. It is said that find the cosine Fourier series of f of x equals sine x if it is limited to 0 and pi over 2. It is. Okay, I have a solution for that. I call that half domain expansion. Half domain expansion. It is said that to find the cosine Fourier series, cosine is an even number, and what should we do to make this function, this graph, look like an even function? We should expand it like this. This is our main graph, which is between 0 to pi over 2. We should expand it like this. This is minus pi over 2. This is 1. Okay, we expand side by side. Firstly, we write down the identity of Fourier series. Identity of Fourier series. T equals pi. This is our time period, and L equals pi over 2. As it is an even function, we do not have Bn. Bn equals 0. We just have An. Bn equals 0. An, which is 2 over L integral of 0 to pi over 2. This. We just calculate the half region and multiply by 2. Okay, we calculate the A naught. A naught equals 2 over L over 2, pi over 2, integral of this pi over 2. Our function is sin x d of x, which is 4 over pi. Sin x is equal to minus 1 over 1 cosine x from 0 to pi over 2, which will be pi over 4 over pi, and times, we put down the pi over 2 is 0, minus 1 times 0 minus 1. This will be 4 over pi. This is our A naught. A naught equals 4 over pi. Okay, we write down the An. An equals 2 over L, which is pi over 2, integration of this f of x, which is sin x, cosine n pi over L, which is pi over 2, d of x, which will become 4 over pi integration of this of this sin x times cosine 2n x d of x. That's it. It's a challenge for us to solve this integration. What do you think we should do? Pause this video and think. Okay, if you have thought correctly, we should use the multiplication to summation equation or relation. Okay, we write down this one, 4 over pi integration of this, which is our formula has 1 over 2 sine of x plus 2n x plus sine of x minus 2n x d of x. We factor out the x, 1 plus 2n times x, and again in this section 1 minus 2n times x. We simply integrate this. It is very easy. 4 over pi times 4 over pi times 1 over 2, and sin x is equal minus 1 over 1 plus 2n cosine 1 plus 2n times x and plus minus again, minus 1 over 1 over 1 minus 2n cosine 1 minus 2n x. That's it. In order to memorize this, sine was an odd function, cosine an even function. It should be an odd function. It is odd. Sorry. Okay, it was from 0 to pi over 2. It is very easy to write down, to solve this integration, and just with substitution. Put firstly pi over 2, second one 0. Then we will have an of equals 4 over pi times 1 minus 4 and 2. Okay, our desired function of sine x in the indirect limited region will become a naught 4 over pi times 2 plus summation of infinity an, which is 4 over pi times 1 minus 4 and 2 times cosine 2 and x. That's the cosine Fourier series of this function in this region, in this limited region. Okay, I want to clarify the point that I used in the last example. If it was said to find the Fourier series of this type of function, it is an hypothetical graph. We just simply copy this side by side. Let's start from here and this is a flower, and again this is 2h, this is minus h, 0. If we have been asked to find the cosine Fourier series of this function, we make it an even graph. To make it even, it should be symmetric, corresponding to y-axis. That look like this, then expand it side by side. It's a hypothetical, just a graphical, abstract. It is not very exact drawing. That's it. If we are asked to find the sine Fourier series, we just make an odd function that look like this. This is minus h. This is 1 minus 1. That is, and then we expand side by side. That's it. Hope you understand this clearly. Okay, that's the ending of video. Hope you understand all the lessons that I teach you. If you like this video, please feel free to subscribe to my YouTube channel right now. And visit mechunion.com to subscribe to our newsletter that I only share very specific knowledge to my subscribers only. If you have any thoughts that think you will improve my work and have a question, please feel free to write down in the comment section that's below this video. Okay, have a nice day, and so